Lesson 3-4, direct variation. Our objective today is to write and graph direct variation equations and to solve problems involving direct variation. So the standard is Algebra 1 4.1. Let's look at the definition or what we're talking about in direct variation. Direct variation is described by the equation y equals kx. You're used to seeing equations with y equals something x plus something, okay? We've seen that in enrichment. You saw that in pre-algebra, slope-intercept form. So what this is saying, y changes directly k times x. When you look at or think about slope-intercept form, okay, let me write that over here. Y equals mx plus b. Okay, when you think of that, what is this right in front of the x? Slope. And that's why I have written this. K is defined as the constant of variation. It's called that, constant of variation, but honest and truly, it's really the slope. So when you are looking at direct variation, you're looking at something sort of in the form of y equals mx plus b, but it would not have a b. What does that tell you about where the lines got to go through? Any ideas, Jared? Through the origin. It means that the y-intercept must be 0. These are direct variations. Y depends completely on this k times x, whatever it is. So let's say that you have to graph y equals 2x. That's it. That's the first one they give us. And it says find the constant of variation and find the slope. Okay, well, let's look at this. Y equals 2x. It's in that form. Whatever number is in front of the x is your k. And you would literally look at that problem, y equals 2x, and say k equals 2. That is the constant of variation. And what is the slope? Well, since it's written in that form, it better be 2. But if they give you these 2 points, then let's look at it. It goes through the point 0, 0. It goes through the point 1, 2. So if we did slope formula, y2 minus y1 and x2 minus x1, because those are the 2 points that I'm using, 1, 2 and 0, 0, 2 over 1, and the slope should come out to 2. But we really already knew that. We really already knew that. So as you're looking at these lines and they give you the equation, the number in front of your x, that is your constant of variation and that is your slope. Okay, now that's part of it. That's just understanding that y is 2 times x every time. So whatever x value you would have in that particular equation, you would take it times 2 and you'd automatically have your y. Okay? So if x was 4, what would y be? 8. Okay? Y depends directly upon x, times 2 in that case. So next, let's look at something else. This time, they're giving us some information, and it says, suppose y varies directly as x. So in other words, we're doing the same thing. And y is 9 when x is negative 3. Use the direct variation equation to find out when y is 15. Here's what they're talking about now. So when we're talking about direct variation, we got to figure out about this k, right? K is how y relates to x. Okay, if you want to see where I got that, let's think about the original equation I had written there before. See that? Y equals kx. How would you solve for k? Right here. How would we solve for k? Ethan? divide both sides by x. And that's why that's how you find it. So it's telling me, suppose y varies directly as x. Y is 9, that goes on top, when x is negative 3, that goes on the bottom. Well, what is 9 over negative 3? Negative 3. So my constant of variation is negative 3. So that means my equation would be y equals negative 3x. If we found our constant of variation to be negative 3, the equation that is described there is y equals negative 3x. So now it says use that equation to find out what x is when y is 15. What do you think I'm going to do? How am I going to figure this out? Plug what?
Plug in y.
Plug in 15 for y. So let's do that. 15 equals negative 3x. How do I solve that? Divide by negative 3. So x would have to be negative 5. So we've answered the question. We've written the equation, and then we've answered what's the value of x when y is 15. X is negative 5. So the constant of variation, we get that from this equation right here, is defined as y over x. So you will have to name constant of variations and slopes from maybe lines graphed, and then also be able to come up with the equation, and then they'll give you a circumstance when y is this or x is this, find the other one. Find the equation first, then plug the value in and find the part that's missing. Any questions? Yes?